Okay, today we are starting Chapter 3. Chapter 3 deals with exploring two variable quantitative data. Investigating relationships between variables is central to what we do in statistics. When we understand the relationship between two variables, we can use the value of one variable often to help us make predictions about the other variable. So in this chapter, what we're going to be doing is investigating relationships between two quantitative variables. So I'm going to give you a quick example. If you ever go buy a used car, obviously, the number of miles that the car has been driven is going to affect the price of a used car. So that's an example of where you have two quantitative variables, and you can actually see a relationship between the two things. So this is section 3.1. Today we're mainly going to talk about scatterplots, and then so this is 3.1 part 1, and then when we do part 2 we're going to talk about what correlation is. So let's start off with a couple of definitions. Two definitions that you need to be familiar with are two terms are response variable and explanatory variable. So let me tell you what a response variable is. So if you have two quantitative variables that you're trying to see a relationship between, the response variable measures an outcome of a study, and the explanatory variable actually helps predict or explain the changes in a response variable. So sometimes in science, I know you guys have used the words independent and dependent variables. So the explanatory variable you can think of kind of as the independent variable, and the response variable is the dependent variable. So you might say, well, why don't we use that in statistics? Well, in statistics, dependent and independent have two different meanings. So when we're comparing or looking at quantitative data, we're not going to use those two words, but because, like I said, they have different meanings in statistics. So we're going to use response and explanatory. So the first thing we're going to do is we're going to look at a couple of examples and see if you can tell which variable is the response and which is the explanatory. So the first example we have here, it's easiest to identify explanatory and response variables when we initially specify the values of one variable to see how it affects another variable. For instance, to study the effect of alcohol on body temperature, researchers gave several different amounts of alcohol to mice. Then they measured the change in each mouse's body temperature 15 minutes later. So what do you think the explanatory variable and the response variable is? Hopefully you realize that the explanatory variable is the amount of alcohol that's given to the mouse, and then the response variable would be the change in the body temperature. So that's kind of like what the study's about, is to see if there is an effect of alcohol on body temperature. So this is the outcome, what you're looking at, the body temperature, and then the explanatory is what it is that is helping to explain the change, to see if there is a change. So for homework, you'll have to do a few of these where you read it and determine which is which. So let's do a couple more examples. So in this problem A, it says the weight in carats and the price in dollars for a sample of diamonds. Well, obviously, which one do you guys think is the explanatory? And then what's the response? So the weight would be your explanatory, and the response would be the price. The weight of a diamond helps explain how expensive it is. So if you go and you look at diamonds and you're going to purchase one, obviously the weight or the size, other things also, obviously are involved. But if you're just talking about weight and price, the more carats of a diamond, the more expensive. Okay, and then the last one here is the SAT math score and the SAT evidence-based reading and writing score for a sample of students. So if you had a bunch of students who took the SAT and you were trying to show the comparison between the two, you might be, okay, if I do the math, is that explaining what you get on your reading and writing? Or if I do the reading and writing, is it explaining what you would get on your math? Honestly, this is kind of a different situation here. And this happens sometimes. Sometimes they just want to see if there is a relationship. So on this particular one, either variable could be the explanatory because each one can be used to predict the other. So like if you think about graphing this thing and you're like, well, what would the x-axis and the y-axis be? This particular example, you could say, hey, here's the math score, that's your x-axis, and your y value would be the reading and writing score. But you could also flip those and have the reading and writing, and then the math score would be your y-axis. So on this particular one, and sometimes this does happen, either variable could be explanatory because each one could be used to predict the other. So sometimes that does happen. Okay, let's talk about the word causation. And when do you have causation? There is sometimes a causal relationship between explanatory and response variables, but you really have to have a well-designed experiment in order to determine a causal relationship. So sometimes I think people, when you have in many studies, the goal is to show that changes in one or more explanatory variable actually cause changes in a response variable. However, other explanatory response relationships don't involve direct causation. In the alcohol and the mice study, alcohol actually causes a change in the body temperature, but there is no cause and effect relationship in the SAT math and evidence-based reading and writing scores. So, you can't really use that word here when you were talking about scatterplots and whatnot, and the response and explanatory variable, unless you have a well-designed experiment. Okay, so let's talk about scatterplots. And you guys have made scatterplots before. When you make a scatterplot, you're going to have to do one for homework by hand, and then I want you to do one in the calculator. Make sure when you make a scatterplot, you label the axis. You need to put the name of the explanatory variable on the horizontal axis or the x-axis. The response variable goes on the vertical axis or the y-axis. If there's no explanatory variable, either variable could go on either axis, basically. Make sure to scale the axis, place equally spaced tick marks, and beginning a convenient number below the smallest value, so you don't have to start at 0. And then you also want to continue to exceed the largest. Make sure that you plot individual data values for each individual. Obviously, you're going to have two numbers, and then you just plot them as a point. Okay. Page 159, here's some basic directions on how to put this in the calculator. On the AP exam, you can be asked to make a scatter plot by hand or on the calculator, so be prepared for both. So I'll just kind of show you real quick. Hopefully, we're going to look at this example here in just a second, but here's an example of a scatter plot, and I just wanted to look at the logistics of it. Make sure you label. This is payroll in millions of dollars, number of wins. This is the baseball, Major League Baseball, and they're just trying to show, what kind of relationship there is. And then, if you look at this, you need to number the axis as well, and then plot your points. So let's say that you had to put this on the calculator. I don't have this note sheet, but this is on page 159 in your book. So I'm going to show you real quick how you would put this on your calculator. So this is the data that we're going to graph, and we're going to make a scatter plot with it. So let's turn on your calculator. And to make a scatter plot, in case you've forgotten, well, let's see where I can get this so you can see the screen a little bit better. There we go. So what you're going to do to make a scatter plot is you're going to push your second and y equals, and you want to go to plot 1, and you want to turn that on. So you kind of arrow over, turn it on, type, we're going to make a scatter plot. That's your first graph there. And we're going to put in list 1 and list 2 and make our scatter plot. Okay, so the first thing you have to do is turn that plot 1 on. Now, to put your data in, you're going to go to Stat, right here, Stat, you're going to go to Edit, and we're going to list this data, which I've already done that, so I'm going to give you a minute to put this data in. So if you need to pause and put your data in. Okay, so hopefully you have your data in. list 1, list 2. Once you get your data in, you want to push graph, and actually you need to push zoom 9 because your graph probably didn't look like that originally. Let's see. Get this better here. There we go. When you put your points in, it probably looked like this at first with no points. So if you push zoom 9 or stat, it'll give you your scatter plots. Okay? So that's basically how you put your scatter plot in your calculator. You need to turn on your stat plot, you need to put your data in, you need to hit graph, and then zoom stat will give you your graph. Okay, so for homework, you're going to get to practice that. All right, let's see. The next thing that we're going to do is we are going to talk about how do you describe a scatter plot. So when you describe a scatter plot, there's some different things you need to make sure to include, characteristics. So to describe a scatter plot, make sure to address the following 4 characteristics in the context of the data. So direction, that's the first thing we're going to talk about. A scatter plot can show a positive association, negative association, or no association. So we're going to come back to these other in just a second. Let's talk about direction first. So when you look at your first scatter plot here, that obviously is a positive direction, because as this is the one I was just showing you in the textbook, this is Major League Baseball in 2016. So the higher or the more they put money, millions of dollars in the payroll, what happened to their number of wins? They increase. Okay. So if you think about it, you know, the better players are more expensive. I guess that makes sense. So that is a positive association. And then we're going to go back and give them better description. This one down here is a negative association. If you look at it, as runs allow increase in Major League Baseball, what happens to the number of wins? It goes down. So we're going to write the description of these. And then this one obviously has no association. Okay. And this is height and amount of sleep. Okay. So let's go back and let's say you were asked to, tell the relationship by looking at the scatter plot. What is the relationship between payroll and number of wins? You could say the positive association indicates that teams that spent more money on payroll typically won more games. Okay, that would be a good way to describe, the relationship between the two. The next one, the negative one. The negative association, this negative association shows that teams that allow their opponents to score more runs typically win fewer games. Okay, so that's what that, if you had to describe the association between the two, like in words, you want to make sure context, you have to put your explanation in context. And then this one over here was height and amount of sleep. So knowing the height of a student doesn't help predict how much sleep he or she is likely to get or receive. Okay? So that's how you would describe. Now, if I ask you to describe a scatter plot, that's just one point of it. So direction, form. A form means, is it linear or is it nonlinear? Okay? The form's linear if overall pattern follows a straight line. Otherwise, it's nonlinear. So strength. A scatter plot can be weak, moderate, or strong. And an association is strong if the points don't deviate much from the form identified. So if it's a linear form and it looks like it's almost a perfect straight line, then you would say it is very strong. Weak would be, it's like linear, but they don't, like their points are pretty spread apart. And then it's weak, yeah, it says if they deviate quite a bit from the form. And then if there's any unusual features, you need to discuss those as well. So an example would be if there's a point that falls outside the overall pattern, or if you see distinct clusters. So sometimes I've seen people Remember socks earlier? This would be DUFS, DUFS. So D is direction, U is unusual features, F is form, and S is strength. So those are the things that you want if you are having to describe a scatter plot. Okay. All right. So I'm going to show you a scatter plot, then we're going to write down one of the scatter plots. So this is in your book. This is Old Faithful. The scatter plot that we're looking at is this one right here on the left. And it's showing the relationship between how long or the duration of the eruption and the time until the next eruption, okay, in a particular month. So if I told you to describe this scatter plot, first of all, the direction would be what? Positive. And I would say it's linear. It's got a linear form. You think it's strong? It's moderately strong, pretty strong. And there are some clusters here, so that would be your unusual feature. So what you could say on this is there is a strong, positive, or moderately strong, positive, linear relationship between the duration of an eruption and the interval of time until the next eruption. Notice I did describe this in context to the problem or to the situation. There are two main clusters of points. One cluster has duration around 2 minutes. Here it is, with an interval about 55 minutes until the next eruption. And then there's another cluster at about 5.5 minutes with about 90 minutes between intervals. So you want to describe any unusual features. Those two clusters are pretty, kind of stand out a little bit. So don't forget it's DUFs. So direction, unusual features, form. Form is linear or nonlinear, and then strength. Like, is it strong? Is it weak? Okay, so then the last thing we're going to discuss is this particular scatter plot here. If you look at this scatter plot is, the reason why we did this one in the notes, it's nonlinear. Okay, you can see a definite curve here. So this has a nonlinear pattern because it is clearly curved. So this is showing the relationship between the average income per person and fertility rates in 187 countries. So if I told you to describe the scatter plot, you would say, you can still say it's pretty moderately strong, negative, it's going in a negative, nonlinear relationship between average income and fertility rate in these countries. Notice it's in context. You always have to say, what this problem is about. Like, what are you comparing here? Put it in context. There is a country outside this pattern right here. If you look, that this is kind of like out of the ordinary, or it's a point that is an unusual point or an individual point that's not like following the pattern of the rest. There is a country outside the pattern with an average income around $30,000 with a fertility rate around 4.7. So when you say unusual features, you can describe an unusual point. You could also do like the clusters that we discussed. So that is what we're talking about today on this first section. We're going to finish this up in part 2, and we're going to talk about correlation.